Hey guys, so first of all, thank you very much for coming. I'm going to discuss today on how we classify the sentiment on opinions within customer reviews. So before we go and dive into the technical details, I'd like to start by telling you how we even got to solving this problem. So for those of you who haven't heard about us, Yopo is a platform that works with online e-commerce brands. We work with over 70,000 online e-commerce brands, and what we do is we help them collect and leverage user-generated content. So what do we mean by user-generated content? User-generated content is any content that could be created by a shopper pre or post-purchase. Usually we refer to reviews, photos, videos, Q&A, star ratings, and so on and so forth. So the first part of our platform is collecting this data. So for example, if we have some client, let's say GoPro for example, and they give us the information of transactions that occurred on their e-commerce site, then we send review forms to shoppers and ask them to submit reviews, to upload photos, and so on and so forth. This is the first part of the platform. The second part of the platform is how we can leverage this user-generated data in order to leverage their businesses. So there are a few ways to do that. The first way is to increase or improve the on-site experience. So basically displaying the user-generated data in some sorts of widgets. Another way to improve their business is to allow them to create social campaigns based on user-generated data, based on reviews, photos, and so on and so forth, or improve their search results on search engines by displaying star ratings on search engine results, and so on and so forth. What we're going to focus on today is gaining insights from consumer feedback based on reviews. So reviews play a significant role in everything related to online shopping. Studies show that more than 88% of users, of shoppers, read reviews before deciding whether to purchase or not. But also, besides the fact that it plays a significant role in online shopping, reviews are also a valuable source of feedback. So before we started this project, we talked to some of the brands that we work with and asked them how do they gain feedback from reviews. So for example, Sandra from Adore Me told us that before, in the past, they used to go over a sample of 5,000 reviews each month, extract consumer insights, run analysis, send reports to every stakeholder in the company, C-levels, products, designers, and so on and so forth. And this inspired us to create a product called Yopo Insights. Now, the idea behind Yopo Insights is to basically describe what people are talking about within reviews. So inside Yopo Insights, the shop owner can basically analyze the reviews per topic. So for example, for topic size, you can see the overall sentiment given by reviewers on the topic size. You can break down by products, break down by countries, read the top mentioned opinions, and even more, you can explore the reviews that are related to a specific topic and a specific sentiment class. And we've had a few interesting success stories. For example, we have a company that found a problem in their production by going over reviews related to quality, or a company that found out a problem with shipment in certain countries because they noticed that the sentiment of shipment in some countries were lower, and they found a problem with a shipping warehouse that shipped to those countries. There's also examples that are not related to problems. We also have an example from Adore Me that saw that for some specific products, the topic husband turned out to be positive. So they created a campaign based on the couple experience. Adore Me sells women lingerie, at least as a man, that's what I know. So they sell women lingerie. They created a couple experience and designed a whole promotion based on that experience and lifted their sellings. Okay, so now that we've established more or less why we wanted to solve this problem, let's dive into the technical details on how we developed the Yopo engine. So basically, the Insights engine is separated into three core components. The first core component is extracting topics and opinions. So for example, you can see here a review. Love these jeans, excellent quality, very comfortable material. The topics and opinions that are extracted from this review, for example, love these jeans is an opinion that it refers to jeans. Shipping took so long, which refers to shipping. This is the first part of the engine. The second part is once we extract these opinions, we want to classify the sentiment of each opinion into one of three categories: positive, negative, or neutral. The third part is once we extracted all of these opinions and classified their sentiments, we want to group similar topics or group similar opinions into topic groups or opinion groups. So for example, shipment, shipping, delivery, shipment cost, shipping time are all aggregated into one topic. Same goes for opinions. So for example, bad, terrible, not good, horrible are also aggregated into one opinion group, so as smelly and stinky. Okay. At the last Data Science Summit, we focused on steps 1 and step 3. Today we're going to focus on the problem of opinion sentiment analysis. So let's formally define the problem of opinion sentiment analysis. In this problem, we assume that we are given a non-composite opinion within the review. Now, by non-composite, I mean a review that doesn't contain two separate opinions of different classes. Our goal will be to classify the sentiment as either positive, neutral, or negative. So a composite opinion would be, for example, the bag is durable but heavy. This contains two separate opinions, which is the bag is durable, which is positive, and the bag is heavy, which is negative. Now, for the case of this problem, we're going to assume that the opinions that we're trying to classify are simple, are uniform sentiment, and belong to one of these three classes. And we'll assume that the first step returned opinions of that form. Now, this problem has been studied recently in the past 2 years. There have been a few papers on this problem, as well as similar problems such as aspect sentiment analysis, where you're given a topic, for example, taste, and the goal is to somehow predict the overall sentiment on the topic taste given by the specific review. So this is a similar problem to opinion sentiment analysis. What's common to all of these problems, and this is the pain point for us at least, is that all of them assume a labeled data set of either opinions or aspects. The problem is that in practice, this doesn't scale. So when you're trying to solve this problem for 70,000 businesses that are spread over multiple industries, it's impossible to create labeled data set every time a new business arrives. So what we try to do is learn the sentiment of opinions based on the only label which is available to us, which is a star rating. Now the star rating has its ups and downs, so it gives some kind of overall implicit indication of sentiment given by the reviewer. Again, if someone says, for example, gives a review, a 5-star review, it doesn't necessarily mean that everything written in the review is going to be positive, not necessarily. So first of all, the star rating is aggregative. It doesn't really represent the opinion, the sentiment of each specific opinion. It's also user biased. Every user has his own range of star rating that he gives. Think, for example, of a review with a 3-star rating. Does 3-star mean neutral? Or maybe it means negative because I usually give 4 or 5-star reviews, and 3 is my indication of negative, for example. It's also noisy. We've noticed that there is more than 1% of star ratings that are completely inaccurate. People who don't understand that 5-star means good and 1-star means bad. So these exist. Probably running demographics on the people who make this mistake could have been interesting, but we didn't. And of course, there's no indication of neutral because, again, a 3-star review doesn't necessarily mean that it's neutral. And besides the fact that we're only going to rely on star ratings, there are a few issues that are more painful than others. So for example, when we classify a positive review as negative, it appears more to the users that use Insights, or vice versa, if we classify something negative as positive. And we're going to try to decrease this error as much as possible. The second issue is if we get a whole topic wrong, because basically through our UI, you're able to browse a specific topic. But if we get a whole topic wrong, for example, price, which is a pretty difficult topic to classify, if we get all of the opinions on price wrong, then we're going to see a lot of mistakes, even if our model is 99% accurate. So, to summarize, we're going to solve the problem of opinion sentiment analysis, and the goal is to do so only by using the star rating. Great. let's start with the Knave approach. The first benchmark approach that we can think of is, okay, there's a lot of models on sentiment analysis. Let's take any model of sentiment analysis that produces good results for reviews, learn it, train it on reviews, and apply it on opinions. So here, again, since we're trying to classify 3 classes of positive, negative, and neutral, and we don't have a class of neutral, what we're going to do is separate the star ratings into positive and negative. For example, 4 or 5 could be positive, 1 or 2 could be negative. The star ratings of 3 can be separated into positive or negatives. They can be duplicated, for example. There's a lot of ways to do that. I won't focus on this in this specific talk. But the goal of this model will be to return a sentiment score between 0 and 1. The thresholds for specifying what's going to be negative, neutral, or positive can be decided by a small validation set of labeled opinions. For example, a few thousand opinions to understand what's going to be negative, what's going to be neutral, what's going to be positive. So it works reasonably well. It has this approach. There are a few issues with this approach. So it usually works well with simple, let's say, single-worded opinions. So for example, good, great, terrific. It's very easy to learn these from reviews and from star ratings. But where does this approach fail? The first place where it fails is having negative comments in positive reviews, or vice versa. So take, for example, my only concern is the weight. So most of the people here are Israelis. They'd probably not write this in a 1 or 2 star review. Usually it's going to be a bit more angry. Here specifically, the sentence of my only concern is the weight is something you typically see in a 4 or 5 star review. And that's an issue. So for example, take the word concern. You see the plot on the bottom right. If you take the word concern and see what's the probability of concern to appear in each of the star classes of 1 to 5, it turns out that concern appears more in 4 or 5 star reviews than in 1 or 2 star reviews, which is a problem because if we're trying to learn something based only on the star rating, then concern might be classified as a positive word. So that's an issue. The second issue, which I'll describe later on in the talk, is modeling relation between words. This is something we noticed in the Knave solution that doesn't work. I'll refer to it later in the talk. What I want to describe now is how we designed our hierarchical sentiment model to solve the problem of opinion sentiment analysis based only on star rating. So this is divided into 4 steps. The first step we're going to do is take the review and split it into smaller fragments. First, we're going to start by splitting it into sentences, which is relatively easy. The second part is splitting these sentences even further according to what is called sentiment transitioning words. But, however, except, although, words that basically shift the sentiments of the sentence from either positive to negative or the opposite. So now we split the review to smaller fragments, which we can, let's assume that they are pretty much uniform in sentiment. Each fragment by itself doesn't have more than 1 sentiment class. It could happen, but we're not relying on it. The second part, let's take a sentiment analysis model, any sentiment analysis model for this purpose, and apply it on each fragment. So we're going to get a score between 0 and 1 for each fragment. We are also outputting the last representation of the neural network before the classification layer. So we'll assume that the models that we run through this hierarchical sentiment model are going to have a last layer of a classification layer, dense and a softmax activation, which is pretty standard. And we're going to output not only the sentiment, but also the last representation learned by the model. The third part is to somehow aggregate between all the representations given for each fragment. So let's go through this step by step. First, we're going to take all of the sentiments that were learned for each of the fragments. We see that on the right. The left part is going to learn a distribution over fragments and learn a weight for each fragment. Now, what we're doing here is the following. We use an attention layer over a bidirectional LSTM layer. I'll explain, at least intuitively, why. Attention layers, for those who know, learns a distribution. And the distribution learns as follows. You take each of the inputs, you apply some kind of linear transformation, the hyperbolic tangents function, which is some kind of a non-linear shifting function. And then you give a score, a weight, for each of the words, independently of other words, and apply softmax activation function. So basically, each of the fragments is learned a specific weight, and all of the weights are normalized in order to get a distribution that sums up to 1. Now, let's say we only use an attention layer without using the bidirectional STM that we used. Attention layer learns a weight for each fragment based solely on the representation and the sentiment of these reviews. Now, when you try this only with an attention model, you'll get that the fragments that receive a high weight will be the extreme ones, the strictly positive and the strictly negative. So let's take, for example, this review. We have very nice shirt, which is positive, but terrible customer service, which is negative. I will never buy here again, which is also negative. So let's assume that we tried to train a model in this approach. Now, when we train this model, when we forward propagate, we see that the first one is positive, the other two are negative. Now, the label, let's say that this is the 2-star or 1-star rated review. So the label that is given to the model, the output label, is going to be negative. Now, the model will back propagate this. Since very nice shirt is something strictly positive, we are going to back propagate this mistake of negative label onto the very nice shirt, which is positive. This is an issue because it can generate noise that can create mistakes later on. So what we decided to do is apply a bidirectional LSTM, a memory layer network, before the attention layer in order to learn a representation for each fragment based on its neighbors. So for example, here when we ran this on our model, we saw that the positive fragment received a very low weight, which is good because we're somehow trying to protect the positive fragment from not being updated by this specific sample. Very nice shirt will be learned by other reviews. So this is the first part of what we use in order to solve this problem. The second part is an additional loss function, because we've established the notion of sentiment transitioning words, but, however, except, and so on. Now, essentially, the intuition is that whenever we see, let's say, something positive, but, we expect the following fragment to be negative. So it's not 100% correct. We look at a few samples, a few hundred samples, and we saw that whenever we see something positive, following but, however, something like that, then with high probability, around 90%, the following fragment is going to be negative. There are a few other examples. So for example, the first one is neutral. We notice that in negative reviews, there's a high chance of the right one. So see in the review and the picture, you have the left and the right. So the right one is going to have also a high probability in negative reviews to be negative. And in positive reviews, it has a 65%. It's not like high, it's high, more or less, probability of being positive. So we use this information in order to incorporate this into an additional loss function that basically says, okay, if you're training the model and you see, for example, on the left side, the model predicts something positive, then we'll enforce a loss function that tries to pull the right side into being negative. So we use the L1 loss function based on these three insights as an additional layer for our training. Great. So this is the first part. This describes the hierarchical model that we used. The second part, which I want to talk about, is the whole issue of modeling relations between words. It's like a very buzzwordy kind of topic, but basically it says the following. We have the sentiment of an opinion can be a complex relation between words. It's kind of trivial. For example, problem, which is negative versus no problem. So no flips the sentiment of problem. Low quality versus low price. So here, the sentiment of low relates to the noun that it is affected by the noun that it's related to. So low quality will be negative, whereas low price will be positive. And you can give more general examples. Candle has no smell. Candle has no smell is usually negative versus a mattress that has no smell, which is usually good. You won't want a mattress. Maybe it's a new kind of product, but usually you don't want your mattress to smell. The problem is that the baseline models that we tried to apply here did not really learn these relations. So we saw that the baseline approaches didn't work well for example, learning the relation of no problem. You usually don't see this when you're trying to learn review sentiment analysis on full reviews, because basically once you see one or two words that indicate that the review is positive, then the model is fine and the accuracy is fine. But once you start looking at specific opinions, we saw that the model did not work well. And it makes sense because usually most of the layers used for sentiment analysis, memory layers or attention layers, they can't really model a not operator. They're mostly a weighted sum of representations that doesn't really necessarily model not. There's the approach of convolution layers that basically finds patterns within the reviews. So there's a few limitations. First of all, they're limited by their width, and we actually tried this and it didn't really work. And it kind of bumped us out. So we tried to see if the model can somehow, in any sort of way, learn these relations. So we tried a brute force approach. We said, okay, let's not try to improve the model. Let's change the vocabulary a bit. So for example, whenever we saw the word no, we applied a pre-processing where we merged the word no with the following words. So for example, in this example, there was no problem with the shipment became there was no problem with the shipment. Or for example, adjective merging. So low that we saw that was problematic, we created variants. Whenever we saw low with another noun that it relates to, and it appeared a lot of times, then we merged. We didn't merge, we created a variant called low price. So we'd have low price, low quality, and created these variants. What surprised us is that this worked really well. It's not a general solution, obviously, it's more like a path solution, but it did provide good results. So we started with a Knave approach. The Knave approach was a document sentiment analysis model that we used to classify the sentiment of reviews and gave us over 95% accuracy. But for the problem of opinion sentiment analysis, it gave lower results. Once we applied the token merging fix, it improved the results of the Knave model. And when we used the hierarchy approach, we were able to further improve the results. The best results that we got is the hierarchy plus the token merging plus additional few rules. So the additional few rules, we took not only the sentiment of the opinion, we didn't only take the opinion, we only took the sentence and the star rating and tried to write additional rules that would somehow decrease the error that we got. So we measured ourselves according to the precision, the overall precision of positive, negative, neutral, the F1 scores of negative and the F1 scores of positive. And the results we got is that the hierarchy approach was a bit better than the other approaches. So great, that's most of the talk. In terms of future work, there's a few other things we want to try in this problem. So first of all, semi-supervised learning. So we tried to learn only from star ratings. Future work is once we obtain a pretty reasonable set of labeled opinions, try to somehow combine between this approach and labeled opinions. The second thing we want to do is remove the token merge dependency, which is a path solution, and we believe that we showed that it's possible for the model to act well in these cases, but we're hoping to find a better general solution for solving these issues. And the third thing is that Insights currently only supports English, and one of the things that we want to do is to support other languages. Great. Thank you very much for coming. Any questions?
Perhaps I missed it, but how did you find these candidates for token merging?
So there's a few ways. So first of all, we had the pain points that we noticed when we developed. So we saw a few issues that were problematic. We didn't take all the possible adjectives. We took a small subset of things just to prove. It was like a proof of concept to prove that this approach will actually work. We have two ways of validating. So first of all, we have a labeled data set that we labeled of a few thousand opinions where we saw that the model did not act well. And we also have a feedback loop from customers that label mistakes that we have in our UI. And we also have an additional route for receiving labeled mistakes. And then we try to solve these based on these detections. Great. Yeah.
According to what you've shown, the positive feedbacks has a higher rate of success than the negative ones.
Mm-hmm.
What
So first of all, so the question is, we had a higher accuracy in positive compared to negative. So first of all, positive reviews are usually, I'm giving like a broad statement, are usually simpler to classify. You also have more positive opinions than negative opinions. So that's one part. The second part is the negative reviews are a bit more complex. At least that's what we saw. And the path solutions that we used, the token merging, solved a few of our problems in the positive area and in the negative area, but still, the negative opinions are a bit more harder to classify. Anything else? Yeah.
It's really nice talk about writing the emotional statements
Yeah.
earlier.
Mm-hmm.
Any thoughts about incorporating that into the solution?
So here specifically, we're not 100% interested in having multiple emotions. For example, okay, well, the user is, the customer is angry is pretty much correlates with negative. The customer fears, I don't know. We could extend this into other classes. At this point, we don't see any justification, at least at this point. But maybe in the future, if we'll see any justification. Yeah.
Do you also use exclamation mark, like three exclamation
Yeah.
marks?
Mm-hmm. Yeah, we parsed it. So the question is, do we use exclamation marks? So yeah, these are parsed as additional tokens.
But are they negative or positive?
You want to come and try? I don't know. I have the models here. It depends on the context. I believe that if you take 3 exclamation points, then it really depends on the bias in the training data. So if you see 3 exclamation points more often in positive reviews than negative reviews, then it's probably going to be classified as positive, the 3 exclamation points, but basically it depends on the bias of the data. Okay, yeah. Yeah. Right. So we don't solve that. We still take 4 or 5-star reviews. We still feed the star rating as some implicit feedback. Unfortunately, we don't have a way to model the user bias because we don't have enough reviews per user. We don't have a way of solving it. It's something we need to take into account when we're solving this problem. It's not something that we explicitly solve, but again, it's a problem that star ratings, an inherent problem with star ratings. Yeah. Yeah. So if I understand correctly, the question you're asking if we applied like 2-way layers? Yeah. So we thought about the solution. One of the solutions was just to see what word no applies to and just flip, like minus whatever. Yeah, so we thought this was one of the 2 candidates for solution, and then this worked. But it doesn't say that, I actually had the same thought. We haven't had the chance of running it, but I won't be surprised if it works. But good question. Okay, we're out of time. Thank you very much.